For today's design challenge, we are going to use a capacitive touch sensor to make a servo motor begin sweeping back and forth from 0 to 180 degrees. We'll use a digital push button to stop the sweeping motion. Now, as we've discussed in past videos, you could replace the touch sensor and the push button with any digital inputs and essentially still use the exact same code. But for today's code, we're going to focus on using these exact sensors since that's what the design challenge explicitly states. But if you chose to use any other digital inputs, that would totally be fine as well. We'll go ahead and minimize our simulator, and I'm going to go ahead and minimize the code here as well. We want to think through what are the best first steps to get started. Lean into this process of writing pseudocode. Start to think through in plain English what exact steps are needed and decompose the problem. Break it down as much as possible to as singular, as granular details as possible before you start writing any lines of code or connecting blocks of code in MakeCode. So let's do that for this problem. We're using this touch sensor to make a servo. We can see how everything's connected. And there's basically only three pieces that I really want to pay attention to. I'm paying a lot of attention to the digital push buttons sensor, that it's connected to pin 0, its signal is going to pin 0, that the capacitive touch sensor is going to pin 1, and that the servo is going to be driven by pin 2. So that helps me know what's being mapped. Now, the next thing I want to think about is there anything I have to keep track of? So do I need to keep track of like a count or a state of something happening? Well, in this case, I do think we need to keep track of whether or not the servo is moving. The servo, remember, is an output, so it's not able to send information back to the MicroBit. So the MicroBit has no way of knowing, is the servo moving or not? So we need to create a variable that lets us keep track of whether or not it's moving. This will help us know whether or not to stop it and which direction we should go, whether it should be turning from the left to the right or the right to left, or in other words, moving from 0 to 180 or from 180 back to 0. So the first thing I'm thinking is let's create a variable. We'll call it sweep. So we've got our sweep variable, and that variable is going to be used just to keep track of the current state of the motor. In other words, is it moving or not? If sweep equals 0, then the motor is stopped. If sweep equals 1, then the motor is moving. So that'll give us just a little bit of a definition that we can use when we're coding to keep track of this. Okay, the next thing we want to look at is there anything we want to do on start? Well, because sweep is going to keep track of whether or not the motor is moving, we want to make sure that we define the value of sweep at the beginning of the program. We don't want to leave to chance. Sweep probably has a value of 0. It actually has an empty value. You call it a null value when it's first created as a variable. So that variable doesn't hold the value of 0. It holds the value of nothing. Like it's not defined. Like there's no number stored in it. Now this isn't entirely true in MakeCode. It tends to instantiate and default to a 0 value if you've not set it otherwise. But it's a good practice to think of this as having a null or no value at all until we've defined it. So we're going to make sure in on start, we want to set sweep, our variable, to, or we could say equal to 0. We want to make sure it holds a value of 0 because right now we haven't told the motor to turn. So it is safe to assume the motor is not moving yet. As we turn our attention to what needs to happen forever, this is where we're going to put any triggering events. So in this case, we're going to let the touch sensor turn the motor on, and we're supposed to let the push button turn the motor off and get it to stop right where it's at so that it could restart once the touch sensor is pressed. So let's focus on getting the motor moving first. So the first thing we would want to do is we can do this a number of ways, but we'll use an if statement. We'll say if, and remember what's going to happen here is we need to read whether or not the touch sensor was pressed. So that's supposed to trigger everything. So that's an immediate starting point. So if, we'll call it a digital read on pin, and we need to go look and see where was the touch sensor connected? Well, the touch sensor was connected to pin 1. So digital read pin P1. If that equals 1, then we should start the motor. Now, I'm going to add the double equal sign here. We've received some questions about this as well. Anytime we're testing whether or not a particular entity, like in this case, the read on pin 1, is equal to a particular value, we use the double equals in syntax languages. When we're defining a value, we tend to use a single equal sign. So if digital read pin 1, in other words, if the capacitive touch sensor was pressed, then what should happen? Well, we want the motor to turn on, but we need the motor to sweep from left to right. And we need it to sweep from left to right essentially until the button is pressed, the push button is pressed. So rather than putting in our motion based on whether or not pin 1 was read, pin 1 was pressed, or the capacitive touch sensor was pressed, we're going to actually use our sweep variable here. So I want to say then, we'll just put it inside of here, then we're going to set sweep to 1, which should trigger the motor moving. So now we want to think about, okay, how are we going to actually make the motor move when sweep equals 1? Again, there's several ways to do this, but since we want to keep the motor moving until another trigger is pressed, while we probably could use an if statement here, since we're in a forever block or forever loop, a best practice would be to use a while loop. So while a particular set of conditions are met, we will do the following instructions. So we will say while sweep, the variable sweep, is equal to, remember we're testing to see if this holds a value, so we use the double equal sign, is equal to 1. So if sweep equals 1, what should happen? Well, if sweep equals 1, then we should move the servo. So we're going to set the servo that's located at pin 2. We want to set that to, we could just set this to 180. We're assuming it was already at 0, but we'll set it to 180. Now, there's a much more sophisticated way to do this that we'll visit later, but for now, we're going to say set to 180. So it's going to move from wherever it was and sort of move relatively quickly to 180. We need to give the program time. We need to give the motor time to run. So we need to pause the program here. But this causes us an issue. This isn't a great way to solve this problem, but for now, we're going to say pause, and we'll pause for a number of milliseconds. And in this case, we'll pause for 1,000 milliseconds, or that is to say, pause for 1 second. It'll take 1 second roughly to go from 0 to 180. So that should be enough time no matter where the servo was. Then we're going to do the exact same thing. Once it reaches 180, we want to change direction. So to set the servo at P2 to 0, and we'll need to pause again for 1,000 milliseconds so that it can make it all the way back to 0 degrees. So inside of our while loop, as long as sweep is equal to 1, this stuff is going to happen. Now, what's interesting is we want to be able to break this loop anytime the push button is pressed. So if we could say out here as like once the while loop ends, though right now there's no way it could end. So we would say inside the while loop, there after some amount of conditions, we could even look for if digital read pin P0 where the push button is connected. If that's equal to 1, then what should we do? Well, then let's set sweep equal to 0. Equal to 0, which would essentially, that would break the loop. So that when we work through here, we would say, I pressed the touch sensor, sweep equals 1. Because sweep equals 1, the servo moves to 180. It then moves back to 0. And then it's going to check to see, hey, did you press the push button? And if you did, then we're going to set sweep to 0, which would mean we would leave this loop and the motor would stop. The problem with this strategy is that it only checks to see if we press the push button. What's happening here? It only checks to see if we press the push button after it's moved from 180 or from wherever it was to 180 and then back to 0. We would have to press the push button at exactly the right time. Otherwise, push button would be sending a signal of 0 whenever this loop finishes. So sweep would continue to be 1 and it wouldn't actually stop the movement of the motor. So we want to come up with a different solution. Now, again, this isn't the most elegant strategy, but it'll work for now since we're still in the beginning stages. We're going to bring in another forever loop, which is a unique thing that MakeCode allows you to do. And here is where we're going to constantly check whether or not the push button was pressed so that anytime it's pressed, we could break the while loop. Okay? So we're going to say if digital read, we'll stay consistent here. If digital read pin P0 is equal to, and remember our push buttons here send a 1 when they're not pressed and a 0 when they are pressed. So we're wanting to see, was it pressed? So if it sends a signal of 0, that means that it was pressed. Then sweep, we're going to set sweep, to 0. And as soon as this happens, it's going to allow this setting sweep to 0 is going to now break the loop. So wherever we're at in this loop, it's going to now have a 0 and it's going to keep us from re-entering the while loop. Again, this isn't the most sophisticated way to do this, but it's a reasonable option to get started. Okay, so with our pseudocode done, we can now go over to the actual code and write this out. So we'll just jump in here and we're going to follow our pseudocode verbatim. So the first thing we wanted to do, we need a variable called sweep. We'll make that here. So we've got a variable, we'll name it sweep. And we're going to set sweep to 0 in our onStart block. I'm going to zoom out a little here so it's a bit easier to see everything as we get moving. So we've got our start block with setting sweep to 0. Now we turn our attention to the forever block. So we're going to come back into MakeCode, and the first thing we need is a if statement. So we'll say if. We go back into logic and grab a comparison element. So if, now we have our variable. Oh, sorry, we're going to need a pin because we want to reference whether or not this was pressed. So if we go to advanced, we're going to scroll down to pins. If we want a digital read, and remember, we're reading the touch sensor, which was connected. We'll double check here. The touch sensor its signal is connected to signal P1. So we'll come back into MakeCode and say digital read on P1. If digital read on P1 is equal to 1, what does the pseudocode tell us? If equal to 1, we're going to set sweep equal to 1. So we go to our variables and say set sweep to 1. Now, as a reminder, this does not make the motor move. All we've done is change the value of the variable sweep. We're going to use the variable sweep to decide whether or not the motor should move. The value of sweep will help us make a decision about whether or not to move the motor. So then the next thing we said in our pseudocode was, okay, we've done this part. Let's look at the while loop. We're going to drag out a while loop, and as long as sweep is equal to 1, we're going to sweep the servo from wherever it was to 180. We'll pause for 1,000 milliseconds or for a second, and then we'll sweep back to 0. So let's pull those blocks in. We're going to go to loops. We want to do a while loop. Notice the hexagonal shape here. We need a comparison block because we're looking to see, is a condition true? Is there a condition that's been met? In this case, the condition we're looking to see is, does the value of sweep, if it's equal to 1 or while it's equal to 1, we want to do the stuff inside of here. Well, the stuff inside of here is set servo to a particular degree. The problem is I don't have a way to get a set servo. So this is a new thing we've done, and this is new to us in the design challenges. We're going to go to extensions. And what extensions are is they're essentially little libraries or packaged functions that allow us to grab what we want. The first one that I clicked is now included in my blocks of code. So I'll go to servos, and this just gives me more blocks that have stuff that's pre-written behind the scenes to help us use the servo easily. So I see I've got a positional servo, meaning I don't have a continuous servo. I have a servo that runs from 0 to 180 degrees that can accept a positional value. So I'm going to set servo. And we said the servo was connected at pin P2. I'll double check my wiring diagram. The servo, as a reminder, the yellow wire from the servo, the signal wire was connected to pin P2. I'll jump back into my make code. So set the servo to P2, and then remember in the pseudocode it said we need to pause. And we need to pause for about a second so that it has enough time to make it from 0 all the way to 180. Now the next thing we're going to do is set the servo. Oh, we forgot to change the value. We're going to change that to 180. And then we're going to change it back to 0. We're going to move back to 0, and we'll need to pause again. So we'll just duplicate the pause and drag that in. This code handles all of our sweeping motion. Now that's taking care of our first forever block. All of that's included. The last thing we have to do is to be able to stop the servo with the press of the push button, which we're going to use another forever block. So we'll go back to basic. We'll pull in another forever block. And in this forever block, all we're going to do is use an if statement, and we're going to set sweep equal to 0. Well, since that statement is very, very similar to this one, I can duplicate this. Notice I've clicked in the if block and selected all the yellow. I'll duplicate that, and it'll pull everything that's there, and I'll drop that into this forever statement. Then I just have to make a couple modifications. In this case, I want the push button, which is I want to read the push button, which is connected at P0. And I want to say if the push button sends a value of 0, which is when it's pressed, if that happens, I want to set sweep, the variable, to 0. When I set sweep to 0, that breaks the condition. It no longer satisfies, the variable no longer satisfies the condition for the while loop. So the motor will no longer be able to turn. It's only turning because we're telling it to move in here, to move to different positions. So by the moment this variable sweep is set to 0, we no longer enter the while loop, and the motor will not be told to turn anymore until we've pressed the digital touch sensor, or the capacitive touch sensor, which resets sweep back to 1 and would re-enter us in that loop. As a reminder, we're running the computer science cohort of cohorts for anyone who's interested in learning more about physical computing. We're a group of teachers in Southeast Tennessee looking to get better at this kind of work. If you have information you'd like to share, tips, tricks, other tutorials, please include those in the comments below. We're better together, and we enjoy the opportunity to learn alongside other people. Thank you.